Today's lesson is on how to integrate problems that started out as logarithms. So let's first talk about how to take the derivative of a logarithm. So when we had problems like this, where we had y equals the natural log of 4x minus 3, when you take the derivative of that, remember that the rule is that you take what's in the brackets, which is the argument, and you put it on the bottom, and then you take the derivative of the argument and you put it on the top, which in this case would be 4. Okay, I want to show you two other examples because it's going to lead into what we're going to talk about in a minute. First of all, if I have just the natural log of x, what would its derivative be? Its derivative would be the argument on the bottom, x, and its derivative on the top, which is 1. Now look at this one. What is the derivative of the natural log of negative x? Well, let's see. Oops, I forgot my derivative sign on the previous problem. So if I put the argument on the bottom, negative x, and I put the derivative on the top, which is negative 1, I still get 1 over x. So I have two problems that give me the exact same derivative. I'm going to come back to that in just a minute. So let's talk about how the integral of a natural log actually works. What it does is it solves the problem, apologize for that, it solves the problem of how you integrate something where you have x to the n dx. Well, first of all, that's just the power rule usually. And what do? We raise the power of the x to n plus 1. We put the reciprocal in the front of it, 1 over n plus 1, and we put a plus c on the end. However, there is one situation where the value of n will not work. And think about what that would be. What is the one value of n that I am not allowed to plug into this scenario? That value happens to be negative 1. Because if I substitute negative 1 right here, that means negative 1 is going to go right here, which means the bottom of the fraction is going to be a 0. And you can't have 0 on the bottom of a fraction. So let's talk about what does that mean. So if the problem is x to the negative 1 dx, well, that happens to be the same thing as 1 over x to the positive 1 dx. Do you see that? Negative 1 means it goes on the bottom and turns into a positive exponent. Now, we just looked at that over here. However, if the derivative is 1 over x, I could have two different answers. I could have ln of x or I could have ln of negative x. So how do you know which one it is? You really don't. So what we do is we write it as the natural log of the absolute value of x plus c. That way, whether it's positive x or negative x, it takes care of both of them. So this is the key for today. When you have an integral of 1 over x dx, the ln has to be an absolute value here when you're finished. Very, very important that the absolute value bars are there. You will probably be marked down on any assessments if you don't put them. All right, let's take it a step farther. If we have the integral of u to the negative 1 du, that's the same thing as the integral of 1 over u du, which would then be the natural log of the absolute value of u plus c. So as we go through and do U-substitutions for this lesson, that is what you're going to be looking for. You're going to be looking for a scenario where you have 1 over u du. Okay, let's do a couple of practice problems. First example, we have the integral of 7 over x dx. Now, if you look at this, up until now, every one that we've done, the u has been the quote-unquote inner function. In the original problems, u was the inner function, Actually, the exponential u was the inner function being the exponent because the exponent is inside of the e. Now, the u is going to be the denominator most of the time. So, u is usually the denominator. And I will show you when it's not in a minute. So usually when you have fractions, try to see about u being the denominator. Now I'm going to kind of go a long way around for this problem, but I'm going to come back and show you a really quick shortcut just for this specific problem. So using my method I just told you, u is the denominator x. And so du would just be 1 dx. So I have everything I need. If you're doing a U-substitution where u is x, you're not doing much to the problem. You're not simplifying it at all. So this was kind of a way that we didn't really need to go. However, we have this little 7 sitting up here that we have absolutely no use for. I believe I told you in a previous video that anytime you have any extra numbers that you don't need, remember that they can move out of the integral. So I'm not going to change this one to use. I'm just going to use it as it is. I have 7 integral 1 over x dx. This one now matches this one up here. So it's going to be 7 ln absolute value of x plus c. And that's your answer. Let's do one that's a little bit harder. This thing is jumping around today. I don't know why. Let's do the integral of 5 over 6x minus 2 dx. Now, the denominator is much more complicated than the last problem. So a U-substitution would be a good idea at this point. So as I mentioned up here, u is usually the denominator. So that's what I'm going to do for this problem. I'm going to say that u is the denominator. 6x minus 2. du equals 6 dx. Okay, so the denominator is u. I need a 6, I have a 5. If I needed a 6 and I had a 3, I could just multiply the inside by 2 and make it a 6 and then the outside by 1/2. That doesn't work in this case because, well, it does. It's a little more complicated. Do you know what you would have to multiply a 5 by to get a 6? Some of you are shaking your heads yes, some of you are shaking your heads no. If you don't want to go down that road and try to figure that out, all you need to do is take the 5 out and put the 6 in, and that takes care of the problem. So we're going to write the 5 outside. I'm going to put my 6 in, and I'm going to put my 1 over 6 outside. So if I bring the 5 outside to go with the 1 over 6, outside I now have 5 over 6. Let's change that 6, it looks kind of funny. Okay, so this here is du. The 5 is gone. The bottom is u. What goes on top? A 1. All right, so now I have changed my integral to be totally in terms of u. And I'm going to pull this script down just a little bit. Now you can see that my integral here matches this integral here. And so now I can jump to the conclusion that I need to jump to, and I'm going to write it out to the side since I'm writing out of room. This would be 5 over 6 ln absolute value of u plus c, and then I'm going to change it back to 5 over 6 ln absolute value of 6x minus 2 plus c. All right, so assignment. That's pretty much everything you need to know for this lesson. If you are doing the Griffith lesson, it is section 4.3, which is on page 113. And if you were working out of the Delta book, this will be section 20.02, which is on page 350. All right, I want to talk for a minute about the Griffith book. It is divided into 3 sections on this page. The first section is pretty straightforward, like the first example. The second section is like a second example, but the third section is a little bit different. Everything in the third section has a denominator that is a single term with a rather complicated numerator, unlike the first section. So when you go to work these problems, these are problems where you have to break them into separate fractions in order to do it, because if you say that u is the denominator, du is definitely not going to be the numerator. So you have to go about it a different way. So just a word of advice as you go on from 28 to 36, that you need to break those into separate fractions, clean them up. Some of them will be power functions when you clean them up. Some of them will be natural logs. So you may have answers that have a mixture of power functions and natural logs. The last thing I want to say is do not forget to put the absolute value bars on your answer, and also do not forget to put plus C on the end. All right, good luck with this lesson. Let me know if you have any questions.